Hi, I am Amardeep and I shall be with you for the duration of this course. This course covers the minimal web API of ASP.NET Core. The IDE that I shall be using is Visual Studio 2022 and I'll be on a Windows PC. The start of this course is slow, so you get sufficient time to understand the basic fundamentals behind ASP.NET Core Web API. After that, we touch upon Swagger and OpenAPI for documentation of Web API. Testing of Web API is explained with the HttpRepl tool that comes with the Visual Studio. We shall also learn how to call various Web API from desktop applications such as C++ application, such as a C# console application and a C# WPF application also. A web API can accept parameters from a route template, from a query string, and from a header variable. This course covers all such scenarios. We also cover file upload with web API and various authentication strategies like header-based authentication, basic authentication, JWT authentication, and social media-based authentication. This course adds to your existing skills if you are a professional, and if you are a student, then this course helps you score better in your college projects also. You must also be aware of the prerequisites. You must already be having a working knowledge of C# and the entity framework for database connectivity that we use in these web API. I hope you will enjoy this course and I welcome you to join this course. Thank you. Let us first understand the concept of Web API. A Web API is a function on the server side that returns data in a format such as JSON or XML. This Web API function can be used to execute an update, delete, insert query, and it can then return a simple code for success or failure. A web API is different from a ready-to-render HTML page. It returns raw data. It is up to the calling application to use that data in whatever manner it wants. For example, a desktop application could use that data to populate a drop-down or populate a list view. Similarly, a mobile application can render that data through its own UI elements. A client can call a web API through a GET request, and it can even call it through a POST request also. There are other requests also possible, PUT, delete. We'll talk about all of them as we go in this chapter. A web API can accept parameters also. The parameters can be sent as query strings or can be sent in the body of the HTML message. Now we shall set a project for learning about the web API. This will be a basic setup. We shall keep adding API in the next upcoming tutorials, but right now let us set a simple project. First of all, create a simple ASP.NET Core project and open the Solution Explorer as you can see here. Add a folder called Models so that we can keep our model classes and DB contexts in this folder. Right-click this folder and add a model class called Doctor. Double-click and open this file so that we can examine the model class. This class has three properties: ID as an auto-generated property, fees is a numeric property, and name is a string type property. We have also added a DB context class for database communication. Open the Solution Explorer, locate the index.cshtml file in the Pages folder. Double-click and open it. As you can see, this is just a file of some text. We are not likely to use this file in this chapter. It is just a home page for our project. Open the Solution Explorer again and locate the program.cs file. Double-click and open this file. First, we have listed two NuGet packages that must be installed. One is for the Entity Framework Core and the other is for SQLite database. Then we have configured the service for SQLite database. Notice that the connection string is used for using it as an in-memory database. This is nice for testing purposes. After that, we have added services for Razor pages. Then we have used the DB context for adding some test data also. The ensure create method is for creating the database, and after that, 2 records have been added for use in our Web API tutorials. And lastly, the application is run. We can run the application to open the home page. This confirms that we have no compilation or other errors so far. We are now ready to add Web API in the next coming tutorials. Thank you. In this tutorial, we shall add a Web API that allows us to get all the records of a table. Please do note, however, that such a query is never done in a real project. It is invariably qualified with some parameters that return a lesser number of records. But this is a tutorial, so let us get started with a query that will return all the records of a table. As we told in the first tutorial, a Web API is just a function on the server side. This function is executed through a URL, and let us decide for this tutorial that the URL would be a readable URL like /doctor/all, and /all would have been equally good. Similarly, /API/doctor/all, that would have been equally good. The point is that we have to decide on a URL that will be bound, that will be connected to our Web API function. The next step is to connect this function, this URL, to a function on the server side. This is also called mapping a request to a function. The easiest way to map a GET request is to use the map_get function of the web application class. This function takes 2 parameters. The first is the relative path of the URL, and the second is a lambda or a request delegate that contains the body of the Web API function. In our case, we will have a mapping like app.mapGet. The first parameter is a path to the URL, the segments. The second is the lambda that will be executed when this URL is hit from the browser. Let us do it practically. Open the Solution Explorer of the starting project that we created in the previous tutorial. Locate the program.cs file, double-click and open this file so that we can examine the code. Recall that we added a DB context for an in-memory SQLite database. This we have done in the previous tutorial, and after that we added some test data to the doctors table. This is the data that we have to query now, and now just after that we have added a map_get request. This request maps the URL to a lambda that takes our DB context as a parameter. The return statement is used to return a list of all the records, and most of the magic is handled by the ASP.NET Core engine. First of all, it makes the DB context available as a parameter. This is all magic that is handled by ASP.NET Core for us. And the second is that it will format the result as a JSON string and send the HTTP response as a JSON string for us. And lastly, let us call the Web API. Since it is a GET type of request, we can open the browser and open the URL /doctor/all. And we verify that we indeed get a list of all the records in the table. In the next tutorial, we shall learn how to pass parameters to Web API function. Thank you. In the previous tutorial, we learned how to write a Web API that accepts no parameters. We executed it to return all the records of a table. And in this tutorial, we shall add another Web API that accepts a parameter and returns data on the basis of that parameter. Let us first learn how to decide on the URL of an API that accepts parameters. The technique is to add the parameter as a segment of the URL to the API. For example, if the API is /doctor/fees and let us suppose the parameter is called AMT, then the URL for the API would be /doctor/fees/AMT in curly braces. Notice that the curly braces are required to define the root parameters. We can add some root constraints to this parameter. The first is that we can restrict its data type to an int type so that only numeric parameters are matched. For this, a data type constraint is specified in a template like this /doctor/fees/amt : followed by int. Int is not the only possibility. We can specify various other data types such as bool, datetime, decimal, double, float, GUID, long, and even regular expressions can be specified. You will have to refer MSDN documentation for all these finer detail. And next, a range constraint can be added also. For example, we can specify a minimum value. A minimum value of 0 can be specified like this: doctor, fees, AMT, int, min, followed by the minimum value that we want to specify. A benefit of root constraints is that if a URL doesn't match the template, then the ASP.NET Core engine rejects that request before it reaches the API function, which prevents any disruptive exceptions from being thrown. A 404 not found response is sent, as we will verify in a moment. Next, we add this new web API to our program.cs file. Open the Solution Explorer and locate the program.cs file. Double-click and open it so that we can examine the code. This is the program.cs file, and let us scroll towards the end where we have already added the new API. As you can see, this API now accepts a parameter called AMT, and that it must be an int type and of a minimum value of 0. It returns all the records that have a fees value that exceeds the specified parameter. We can now run the project and call the API by passing a parameter of value 100. The root now becomes doctor fees 100. Run the project and verify that only the matching records are returned, and therefore the API is working as expected. And lastly, let us try a URL that will fail the constraints. So we can try this URL doctor fees ABC, and we verify that the request fails with the 404 error. You can obtain the source code from the attached downloads. Thank you. In this tutorial, we shall add a web API of GET type that takes an ID as a parameter and returns a record for that parameter. Let us first decide on the URL of this API. The URL has to contain a parameter called ID, so we should use curly braces and append this parameter to the path of the URL, like /doctor/ID in curly braces. Next, let us add this API to the program.cs file now. Open the Solution Explorer. We are using this project to learn Web API, and with each tutorial we are adding a Web API and testing it. Please refer the first tutorial of this chapter where we created this simple project. You can even find the source code for this and the other tutorials in the attached downloads if you are following our course on ASP.NET Core. Double-click and open the program.cs file and scroll a few lines down to reach the part that you are seeing here. MapGet function is used to add a web API. The first parameter is the root template. The second parameter is the function that executes when the API is called by a calling client. If the record can be found, then the record is sent with a 200 OK response. And notice that most of the work is being done by the ASP.NET Core functions. We need to write only a few lines of code. If there is no matching record, then an HTTP 404 response is sent. Finally, let us run the project. Type the URL /doctor/1 for the record of ID 1. We verify that the server responds with the JSON formatted record of ID equal to 1. Everything is working correctly. Thank you. Postman is a software that can be used to easily and conveniently run and execute Web API. It can be installed as a desktop application. The software offers a lot of functionality, but we shall be using a small part of that relevant to just our Web API requirements. Visit postman.com website and download this software. As far as I understand, the software can be downloaded and used free of cost for small testing purposes at individual level. I was able to download it without the need of signing up for their account. Install the software and get the shortcut on your desktop. Double-click and open the Postman window. The window seems too complex and full of features. There is a drop-down that allows you to choose the type of request. In this chapter, we have done only the GET type of API so far, so choose the request as GET. There is a text box adjacent to the drop-down. We have to enter our target URL in this text box. Let us type microsoft.com. Just below this, there are various options for sending data to the server. We can add query string name value pairs. We can specify request headers. We can specify data to be sent as the body of the request also. You can examine all these possibilities yourself. I will take them on need basis. For example, I'll use this when I'll be testing a post type of Web API. For now, we have no data to send. So hit the send button to send a GET request to the home page of this URL. As soon as the request completes, we can see various items of response data. For example, body of the response contains the HTML received from the server. Then we have cookies, headers, and other things. After this brief introduction, let us test our own Web API now. Open the project and run it in a browser so that we can obtain the URL. Just put any Web API there and ensure that an API gives a response. In our case, our API is of GET type /doctor/1. This API returns a JSON string for a record of ID equal to 1. We did it in the last tutorial, so you can look at that tutorial if you need continuity. Copy this URL and paste it in the Postman window. We have no data to send, so hit the send button straightway. We observe that we receive a JSON response immediately. This is how we can use Postman to test a Web API. Please note that the software is more helpful for testing requests such as a post request, something that is the topic of our next tutorial. Thank you. A Web API of the post type is used to create a new record. For example, if we have to create a new record of a doctor, then we have to use a post API to send the relevant fields for creating a record. A post Web API is created with the map post function. The first argument is a route pattern for the URL for the API, and the second a function that accepts a parameter containing the record to be created. For example, if a record of type doctor is to be created, then the parameter would be of the type doctor. Another alternative is to pass each property as a parameter and then assemble an instance out of those properties by using certain constructors or whatever way we use for creating an object out of those properties. But this is done very rarely. Let us now add a web API of the post type to the project that we are doing in the past few tutorials of this chapter. Open the Solution Explorer and locate the program.cs file. This is the file in which we are serially adding our minimal web API. Double-click and open this file. Scroll to the part that you are seeing here. As explained earlier, we have used the map post function to describe the route to our web API. The first parameter is the route pattern and the second parameter is the delegate that executes when a post request is matched. Dependency injection provides a DB context which is used to add a record to the database. Assuming success, a response of 201 is sent with the results.created function. The first parameter of this function must be a URL that can be used to access the new record, and the second is the record that has been created just now. This is a requirement of the HTTP protocol. Please visit w3.org for more on this protocol. If a URL for the new record is not available, then we can send 200 OK or 204 no content. In case you ever need to do that, then the relevant methods have been commented in the code that you are seeing here. Finally, let us test our web API with Postman. First, run our web application to start the server. This will also help us know the port and URL to the application. Next, open the Postman software. Select the request type as post. Type the URL as /doctor. The mode of data exchange in minimal web API is through JSON strings. So the data to post must be a JSON string. So select body and then select JSON format, and after that type the JSON for the new record. The property name as doc3 and fees as 200. This is the data for the doctor which will be used to assemble a record of doctor type as we were explaining earlier. Hit the send button. We verify that the response is 201 created and the JSON for the newly created record can be seen in the response from the server. This verifies that we have done our post API with success. Thank you. An HTTP PUT request is used for updating an existing record. For this, a client has to send the unique ID of the record along with the entire updated record. Partial updates are not done with the PUT type of web API. Partial updates are rather supported by an HTTP patch request. But this is not the topic of this tutorial. Today we shall focus on the HTTP PUT type of web API. A PUT web API is created with the map PUT function. The first argument is the route pattern for the web API. The ID of the record is a part of the route parameter. If your table has a composite primary key, then the route pattern can be designed to include more segments so that all the keys do get included as a part of the route. The second argument is a function that receives the entire entity or object that has to be updated. The function also receives the ID of the object. This ID is the primary key as extracted from the route template. Passing the ID as a separate argument may seem redundant because primary key is in any case also a part of the object that is received as an argument. But this takes care of the possibility where the primary key itself may need an updation. So it is for that situation that ID is an additional parameter. Let us now implement a PUT type of Web API in the simple project that we are discussing for this chapter. Open the Solution Explorer and locate the program.cs file. Double-click and open this file. Scroll to the part that you are seeing here. As explained earlier, we have used the map put function. The route is doctor/id and it contains the id as a route parameter. Dependency injection provides us the DB context. First, the incoming id is used to locate the current record from the database. After that, values are updated and the changes are saved to the database. Results.content is used to produce 204 response as per the requirements of the HTTP PUT request protocol. Finally, let us test the Web API with the Postman software. First, run the application to ensure that the local server starts running. Take note of the URL and next open the Postman software. Choose the request type as PUT. Type the URL containing an ID of the record to be updated. We have set the ID as 1. The body of the request has to be in JSON format, so type all the updated properties of the new object in JSON format as you are seeing here. And next hit the send button. We verify that we receive HTTP 204 no content as the response, which verifies that the map PUT Web API has responded as expected. Thank you. An HTTP delete request is used for deleting a record. The server sends a 200 OK response on successful deletion along with the item that was deleted. Alternatively, it can send 204 no content if the deleted item is or cannot be included in the response. Let us now see the implementation of this API in this tutorial. A delete web API can be easily created with the map delete extension on the application class. The first parameter of this function contains the route template that includes a parameter for the unique ID of the record that has to be deleted. The second argument is a function that receives that ID as a parameter. This parameter is provided by EF core from the matched route. Open the project that we are discussing in this chapter. Locate the program.cs file and open it. Scroll to the part that you are seeing here. If you are following our course on ASP.NET Core, then the project file can be obtained from the attached downloads also. As you can see, we have used the map delete function as explained previously. DB context is used to find and delete the record from the database. A 200 OK response is sent on successful deletion. The JSON for the deleted object is also sent as per the requirements of the HTTP protocol. Run the project to open the home page so that the server is started. Take note of the URL and open the Postman software. Select the request type as delete. Type the URL with the route parameter value of id is equal to 1 as you can see here. There is no data to be sent with the request, so we can click the send button. We verify that we receive 200 OK from the server along with the JSON of the entity that was removed. This means we have successfully tested the minimal delete web API. Thank you. We have been working with a model class consisting of 3 properties: ID, name and fees, if you recall in our previous tutorials. All the 3 properties have participated and have been exposed in JSON communication through every web API that we have discussed and written in the past tutorials of this chapter. This is called overposting. I'll come to the details of overposting in a moment. Now let me just give an introduction. But what happens if there were a property such as an email address that we did not want exposed? This tutorial presents a solution through the concept of a data transfer object where you can prevent certain properties of an object from participating in the Web API process from the process of JSON communication. Let me briefly discuss about overposting. We know that model classes are exchanged as parameters and response objects. A model class is sent as a parameter of a function when you call a web API, and in the response the same model class or a collection of those objects is returned. The ASP.NET Core engine, it takes care of the translation of a C# type to a JSON string and vice versa. So every public property of a model is exposed in this communication. I say every public property. The entire object is shuttled between a client and a server, even if a small subset is relevant. This is called overposting, when you are sending entire thing instead of just the required part. Overposting might be undesirable for various reasons. One of them is bandwidth, and more importantly, it could be due to security also. So what are the solutions to this problem? One solution is to use a shadow model class that contains just the properties that we want exposed. A shadow model class with only the properties that are relevant for our communication. Such a class is called a data transfer object. Consider a model class such as this one. This class is the same Doctor class that we have been working with, except a new property for email that we want to hide from every Web API communication. The solution is to create another record class called Doctor DTO that contains all properties of Doctor except email. So create a Doctor DTO class that contains all the properties that we actually want and exclude the properties that we want to hide. Notice that we have used the record keyword to emphasize the fact that this is just a read-only type meant for data exchange. If you are not familiar with this keyword, then you can either go through the new C# syntax, or you can equally use the class keyword for that. It won't impact much on our learning right now. This record also contains a constructor that is used for translation of a doctor to a Doctor DTO. Let us try to understand a few rules. Then we will show an implementation, but implementation will come in the next tutorials. But let me now suggest some rules for there. I have written a few rules for using a DTO class. The first is that whenever your API takes a parameter of type doctor, replace that parameter by Doctor DTO, because your client will communicate only through the properties contained in a DTO. If you have written a API that accepts a parameter of type doctor, now it is time to replace that by a parameter of type Doctor DTO. In fact, it will be more meaningful also to use a DTO, because only these properties are going to participate in our communication. And inside the body of the function that will handle your request, the Doctor DTO can be converted to a doctor by copying the respective properties. You can read the Doctor DTO and convert it into a doctor object, which you might be requiring to use somewhere in your EF core, in your entity framework core communication. I will show the details of this in the next tutorials, but right now the second is that whenever your API returns a type of doctor, replace that by Doctor DTO by using its constructor. The constructor will convert your doctor into Doctor DTO. And thirdly, wherever your API returns a list of doctor objects, replace that by a list of Doctor DTO objects by using a projection function such as select, like await context.doctors.select x goes to new Doctor DTO x. So this one will create a collection of Doctor DTO objects in place of the collection of doctor objects. You will see the details of its working in the next tutorials. We shall modify our Web API in the next tutorials. Thank you. If an API has to return a collection of records and if we do not want entire objects to be transmitted, then we can use a data transfer object to return a small subset of properties, just the required subset. For this, you have to be aware of the concept of overposting, so please refer the previous tutorial, Overposting in WebAPI and a Solution with Data Transfer Object. It will help you get started with this tutorial, so please refer the previous tutorial where we have added a DTO class for the doctor as you see here. The actual entity is a doctor, but it contains a property called email that we do not want transmitted. To prevent overposting, to exclude that property, we have added a DTO class that excludes this property that we do not want transmitted. Let us now modify our web API. Open the project that we are completing for the past few tutorials. Locate the program.cs file and open it. Scroll to the part that you are seeing here. Take the case of this web API that returns a collection of doctor objects. But we do not want the email property to be sent as a part of this collection simply because it is irrelevant, because it is not required, and possibly because of security concerns also. The solution is to use a projection to return a collection of DTO objects instead of a collection of doctor objects like this. Context.doctors.select x goes to new doctor DTO. We have used the constructor of doctor DTO to convert a doctor to doctor DTO. So this will cause doctor DTO to be sent, which will exclude the property of email automatically. If you are following our course on ASP.NET Core, then you can obtain the project from the attached downloads also. Run the project and make a request to the web API. We verify that we receive the collection, but the email property is excluded. So this is how you can modify your GET request that returns a collection to ensure that we do not overpost any properties that are not actually required. Thank you. This tutorial explains how to modify a post type of web API so that it doesn't overpost data. A post web API receives a data object as a parameter and then adds it to a database, and finally it returns an HTTP 201 created response along with the JSON for the newly added object. We have already covered this in one of the previous tutorials. And for a primer on overposting, please refer a previous tutorial, Overposting in Web API and a Solution with Data Transfer Object. Let me first explain the objective of this tutorial. Open the Solution Explorer and locate the program.cs file. Double-click and open it. Scroll to the part that you are seeing here. Consider this post type of Web API. It receives doctor object, adds it to the database, and then returns the same object in a 201 response. Since the entire object is being shuttled between the client and the server, we can say that the doctor object is overposted in this case. Now the objective is to modify this web API so as to prevent overposting. For this, the communication has to be through a data transfer object, doctor DTO, that posts a smaller subset of the properties. For a primer on overposting, please refer a previous tutorial, Overposting in Web API and a Solution with the Data Transfer Object. Now we can start making the modifications. The first alteration is to change the parameter to a doctor DTO type so that just the relevant properties are received into the handler function. Replace the doctor argument by doctor DTO. This will save us unnecessary conversions of form data, because when it is doctor object, it converts each field into a doctor property, whereas when it is a doctor DTO object, it will transfer only the properties that you put in the doctor DTO. So in this way, it will save us unnecessary conversions of form data. The next is to create a new doctor in the body of the request handler. The properties on this object are set on the basis of the properties received from the parameter. We are copying the respective properties into our doctor object. It is possible now to set other properties such as email in this case on the basis of some synthesis or on the basis of data in other tables. We have a lot of flexibility here because email is one of the hidden properties that we do not want to participate, that we do not want that it should participate in the Web API communication. This property can be now set independently in whatever way you want. The third is to create a doctor DTO out of this doctor so that overposting doesn't take place. For this, we have used the constructor of doctor DTO. With these changes, the API prevents overposting. And now it's time to verify the changes. Run the project to open the home page. This ensures that the server is running. Take note of the URL along with the port. Open the Postman software and select the method as post. And type a body JSON string for the new object as you are seeing here and hit the send button. If you are finding it difficult to understand this Postman, we have already covered this Postman in one of the previous tutorials. You can go and have a look at that. So once we hit the send button, we observe that a DB update error is thrown. This error is because our DTO class Dr. DTO doesn't have a default constructor. A small debugging helped me locate this problem. We missed it in the first tutorials, so let us add it now. Open the Solution Explorer and locate the doctor.cs file and double click to open it as you see here. Add the default constructor. Now again run the application and again open the Postman software as you see here. Hit the send button. We verify that the call succeeds and we receive 201 created response from the server. Other API can be modified in the same way where you can replace the parameters or replace the return type, and I have attached the completed modified project in the attached downloads. You can obtain from there. Thank you. This tutorial explains how a GET WebApi can be called from a C WinRT application. I have chosen WinRT because it contains a lot many pre-written functions that simplify internet access and JSON parsing. I won't be able to explain the details of a WinRT setup, so I have already created a WinRT console application that connects to our Web API and then obtains a string from the application and then parses the JSON contained in that string. The C++ project is available in your downloads. Let me first explain the objective of this tutorial. We will make a GET request to a Web API that sends a JSON consisting of two properties, name and fees. After that, we shall parse that JSON and display the extracted properties. Let us first have a look at the Web API that we have to call. Open the project that we have been discussing in this chapter and locate the program.cs file. Double click and open this file. Scroll to the part that you are seeing here. This Web API responds to a route template /doctor/ID and sends a JSON of the record corresponding to the ID extracted from the route template. We shall make a call for a record of ID equal to 1 So our target address would be /doctor/1. Run the application and allow the home page to open. This ensures that the server starts running. Take note of the URL and the port number. We will need it in the next step. Next, create a console-based C WinRT application and open the Solution Explorer as you see here. Locate the main.cpp file in the Solution Explorer that you are seeing here. This project is available in the downloads attached to this video. Double-click and open the main.cpp file. Let us have a look at the main parts of this file. These are the files that have been included in the pch.h precompiled header file. Next, we have the well-known header for IOStream. A URI is created on the basis of the URL for the web API. An HTTP client will help us communicate with the server, and the response string will be collected as an H string. A try block contains the statements for sending a GET request and receiving the response body. JSON value class is used to parse the string that is obtained from the server side. Get named string and get named number are used to extract the name and fees of the received entity. Lastly, the data is displayed. Run the application now. We verify that the name and fees are displayed successfully. Thank you. This tutorial explains how a POST Web API can be called from a C WinRT application. I have created a WinRT console application that connects to our POST Web API and posts a JSON string to our POST Web API and then obtains a string response from the application and then parses the JSON contained in that string. The C project is available in your downloads. Let me first explain the objective of this tutorial. The central idea of this tutorial is that we have a client-side application that will post the name and fees of a doctor. The posting will be to a post type of web API. And since this is a post type of web API, it will create a new record and send a response to our application. The response string will be decoded and shown on the console window of our C WinRT application. Let us first have a look at the web API that we have to call. Open the project that we have been discussing in this chapter and locate the program.cs file. Double-click and open this file. Scroll to the part that you are seeing here. This is a post type of web API and therefore it has to create a new record. The calling client has to post the data for the record and ASP.NET Core will pack this data into a Doctor DTO argument. EF Core is next used to create a new record and save the changes to our database. Finally, a 201 created JSON is sent back to the caller. We have discussed this API in detail in one of our previous chapters. You can refer that for finer details of this API. And put a breakpoint somewhere in the body of this web API. It will help us verify if our client is able to reach this specific web API. Run the application and allow the home page to open. This ensures that the server starts running. Take note of the URL and the port number. We will need it in the next step. And next, create a console-based C WinRT application and open the Solution Explorer. Locate the main.cpp file in the Solution Explorer that you are seeing here. This project is available in the downloads attached to this video. Double-click and open the main.cpp file. These are the files that have been included through the pch.h precompiled header. These files that you are seeing here, these have been included through the pch.h precompiled header. And after that we have the well-known header for IOStream. A URI is created on the basis of the URL for the web API that we noted in the previous step. An HTTP client will help us communicate with the server, and the response string will be collected as an H-string. HTTP client and H-string are classes of the WinRT framework. You can refer to the WinRT tutorials if you want to know more about WinRT, but here I have assumed that you know about it, and our purpose is to connect to our Post Web API, so we are not going into much detail of that part. Next, we have created an HTTP string content in JSON format. A try block contains the statements for sending a post request and receiving the response body. JSON value is used to parse the string. Get named string and get named number are used to extract the name and fees of the received entity. And lastly, the data is displayed. Run the application now. We verify that the breakpoint in the ASP.NET Core application is hit, and we also verify that the name and fees are received back successfully at the client side console window. Thank you. Swagger makes it easy to document the various web API exposed by your project. The summary of your API is maintained in a JSON-based file called OpenAPI.json. This document is the main document, but we are not required to worry about it in our day-to-day life. It is automatically used to create a web page called Swagger UI, which shows all your web API in a colorful human-readable interface. Each web API can be immediately run and tested, and it turns out that Swagger UI is much more easier than using the Postman software. First of all, let us quickly have a look at the difference between OpenAPI and Swagger. OpenAPI is the specification. It lays down the rules for describing the web API. It lays down the rules for documenting parameters, for documenting the responses, and so on. These rules have been described using XML. Swagger, on the other hand, refers to the software tools and applications that implement the above specification. Some of these tools generate intermediate documents such as OpenAPI.json that I was talking earlier. And there are others like that use these intermediate documents to render the API in a well-formatted GUI-based interface. Examples of such applications are Swagger UI and OpenAPI Generator. We shall talk more about Swagger UI later in this tutorial. So OpenAPI is the specification and Swagger is the software part that implements that specification. Many developers use the two terms interchangeably, so OpenAPI and Swagger are used interchangeably in day-to-day life. These two terms together refer to the applications that generate the documentation and to those that present them and to the rules that are used to generate the documentation. Next, let us discuss Swashbuckle and NSwag. Swashbuckle and NSwag are two main .NET implementations of the OpenAPI or Swagger specification. Both of them include a web-based UI called Swagger UI. You may have already heard of that in the past, and we have already talked about Swagger UI in this very tutorial itself. the details we'll be covering shortly. As an ASP.NET Core developer, we do not have to worry about the finer details of swashbuckle and nswag because everything is handled for us by the ASP.NET Core engine. The only thing we need to do is to configure the middleware correctly. So it ultimately boils down to the configuration file where we have to add a few statements and get our things working. We'll talk about that in the coming tutorials, and for now I'll say you will need the following NuGet package for swashbuckle. Install package swashbuckle.aspnet core. So once you have this package, then the rest of the configuration can be easily done. We shall explain the process in the next tutorial. Thank you. Let us now configure our Web API project to add support for Swagger UI. As we told earlier, Swagger UI is provided by both Swashbuckle and nswag. We can use either of the two, and I shall be using Swashbuckle. The process for nswag is exactly similar. Open the Web API project that we have been completing in this chapter. Locate the program.cs file and double-click to open it. First, we have listed the various NuGet packages that must be installed. These have been listed for your convenience so that you can easily set your own Web API project. The first two of these have already been added, and now we should add the third one for swashbuckle. Open the package manager console and type the command install package swashbuckle.aspnet core. Hit enter and allow it to complete. Come back to the program.cs file again. Just after the service for Razor pages, add a service for Swagger generator as you see here. And after that, we have enabled the middleware for serving the Swagger UI. So these are the only additions required for enabling Swagger UI in your project. Let us test the Swagger now. Run the application and allow the home page to open. Take note of the port number and type the following in the web browser: localhost port/swagger. This you should type in the browser, hit enter, and we observe that a Swagger UI opens. Swashbuckle has used reflection to obtain the list of all your Web API, and let us view it in full screen. As you can see, all the various Web API can be seen listed here. There is a color for each type of API: blue, red, green, etc. This helps you identify the type of Web API. Let's try to run the first API. Click the drop down. Next, click the Try It Out button. We observe that the Execute button opens as you are seeing here. Click this Execute button, and we observe that the server sends 200 OK response along with all the records for this API. You can try execute other APIs also in the same manner. I'll close it right now. Thank you. In this tutorial, we shall learn how to call the various types of Web API from a C# WPF application. I have already created a WPF application that obtains a list of records from our Web API project and renders them in a grid. This is a get all Web API request that queries a collection of records. The same WPF window has a form for creating a new record, and this is done with a call to the Post Web API. When a user clicks a record on the WPF window, a dialog pops up that allows the user to update that record. This will be a call to the PUT WebAPI. The same dialog has a delete button that makes a call to the delete web API. We shall talk about all these communications with the web API in the coming tutorials, and in this tutorial we will talk about obtaining a collection, a get all web API request. We'll talk about the get all communication in this tutorial. First of all, let me give a quick primer on the various useful C# classes that are now available specifically for the purposes of making calls to the web API. These classes handle most of the finer detail for us. The most important thing is that you will need to install a NuGet package called microsoft.aspnet.webapi.client. So you will have to open the package manager console and run this command install package microsoft.aspnet.webapi.client. One of the classes that I was talking about is called the HTTP client class. This class provides various functions like get async, post as JSON async, put as JSON async, delete async. These methods handle JSON serialization, deserialization, HTTP headers, everything from A to Z for us. The class HTTP response message contains the response as received from the server side. A try-catch block is often used to handle error conditions. After this brief introduction, let us now open our WPF application project to examine the various parts. The completed application can be found in the downloads attached to this video. This is the Solution Explorer. Let us first have an overview. The models folder contains the data transfer object class called Dr. DTO. This is the same class that is used in our ASP.NET Core Web API project. Double-click and open it. As you can see, we have copy-pasted it from the Web API project. And notice that a constructor has been commented out because it is not relevant from the perspective of a client application. Next, in the Solution Explorer, we have a dialog window for editing and deleting a record. And lastly, we have the main window that contains a data grid for showing the records. Double-click and open the main window.xaml.cs file. First, we have the namespaces. After that, I have typed the name of the NuGet package. You will have to run this command in the package manager console if you want to get help from the new classes that we are talking about. Then you can see we have a read-only member to hold the IP address of the Web API. This address is configured in the Web API application and we already know it and we have already used it everywhere in this chapter. The main function of interest right now is the load all doctors function. This function uses the HTTP client class that I have explained earlier. Get async method is used to make the get all request to the Web API. The JSON sent by the Web API can be deserialized by using the read as async function. After that, the deserialized list is attached as a data context of the data grid. And that causes the data grid to be populated. Now let us run the applications. First, run the ASP.NET Core Web API application so as to start the server. Allow the home page to open. Next, open the WPF project and run the project. The window opens and shows a list of all the records sent by the ASP.NET Core application. Our communication has been established successfully. We'll take the case of Post Web API in the next tutorial. Thank you. This tutorial continues from the previous tutorial. We have discussed most of the parts there, so please go through the previous tutorial for a continuity. Now we shall call a post web API from our web application and create a new record. We shall use a form on the WPF application to obtain the name and fees of a new doctor record. When the user clicks the Save button, a web API call is made to the Post API and a new record is created in the server side. Let us have a look at the web API that we have to call. Open the ASP.NET Core Web API project that we have been completing in this chapter. This project as well as the WPF application is provided in the downloads of this chapter. Locate the program.cs file and double click to open it. Scroll to the part that you are seeing here. As you can see, the Post Web API receives a Doctor DTO as a parameter. The API can be called through the route /doctor. Run the application and allow the home page to open. This ensures that the server starts running. Next, come to the WPF project. Run the project so that we can visually see the whole thing. As you can see, we have a form for obtaining the data of a new record. There is a Save button also. Let's have a look at the event handler for this Save button. Open the Solution Explorer of the WPF project. Locate the main window.xaml.cs file and open it. This is the file and we have discussed various parts in the previous tutorial. Now we can scroll to the event handler for the Save button. First we make a few validation checks. Then we have used the HTTP client class. This class is the recommended class for Web API communication. A Doctor DTO is created for posting to the Web API. The post as JSON async method of the HTTP client class is used for making the actual call. The response is read by using the read as string async function. This response is shown in a message box so that we can verify the result of this call. Run this application, allow the window to open, enter some data in the text boxes, click the Save button and wait for the response. We verify that the server has responded with the JSON for the newly created record. Everything is working as expected. Thank you. As you must have already seen in the previous tutorials, we have a WPF application that obtains a list of records from our ASP.NET Core Web API application. It shows those records in a WPF data grid. When a row of the data grid is clicked, a dialog pops up that shows a form for editing the record. The Save button for this form is wired to a click event handler that makes a put call to a web API and updates the record. A delete button on the same form causes a call to a delete web API. The objective of this tutorial is to study the code for calling put and delete web API. Open the Solution Explorer of the attached WPF project and locate the file dialog.xaml.cs. Double click and open this file. First we have the namespaces. Then we can scroll down and locate the event handler for the update code. As usual, we have used the HTTP client class for our Web API communication. And then we have created a Doctor DTO on the basis of the form filled by the user. Validation code has not been shown for simplicity. You can add it yourself. Put as JSON async is the main function that makes a call to the Web API. The response message is shown in a message box. Next, let us have a look at the event handler for the delete button. Again, we have used the HTTP client class. The Web API call is made by the delete async function. Finally, we can run the application. First, run the Web API project to open the home page. This ensures that the server is running. Now run the WPF project. If everything goes fine, the records will appear in the data grid. Double-click a row to open the edit dialog form. Make some changes. Change the name of the doctor and change the value of the fees box. These changes will now be posted to the server. Click the submit button and we verify that the server response is received in a message box. Click OK to close the message box. We can see that the data grid now shows the updated values. Similarly, we can double-click a row to again open the edit dialog box. Click on the delete button. We verify that the record gets removed from the data grid. Thus, we have successfully tested the put and delete web API. Thank you. HttpRepl is a command line tool for testing web API. This tool targets the ASP.NET Core environment. And let's have a look at a brief introduction to this tool. We will also learn how to activate it in Visual Studio, and in the coming tutorials, we shall use it to make a few web API calls also. So here is a brief introduction to HttpRepl. It is basically a tool for testing web API. It is a command line tool and cross-platform, and it is therefore available wherever .NET Core is installed and available. It can be used for testing any web API, whether written for ASP.NET Core or for even the classic ASP.NET. It works on localhost, can be used on real web hosting, and even on environments like Azure App Service. And it is very versatile. It supports various types of HTTP verbs such as get, post, delete, put, head, patch, and options. So you can think of it as a quick, lightweight alternative to products like the Postman. And if you are interested, REPL stands for Read, Eval, Print, Loop. For details of this, you can visit the documentation on MSDN. But let me now come to the more practical parts. HttpRepl needs to be installed before you can use it. And now I will explain the installation procedure. First, open Visual Studio and select the menu, Tools, go to Command Line and then Developer Command Prompt. Allow the command line console to open. And now we can type the command .NET tool install Microsoft.NET HttpRepl as you are seeing here and hit the enter key. Allow the process to complete, and if everything goes fine, your installation should succeed. And it can take a few seconds depending on the speed of your internet, because behind the scenes the installation takes from our NuGet package called Microsoft.NET HttpRepl. And finally, let us test if we have succeeded. Type the command HttpRepl h. It will verify the installation of this software tool, and hit enter, and you should be able to see a long list of commands supported by this tool. This H basically means help. So if you see all the list of commands, then that means that we have done it okay. And in the next tutorial, we shall use this tool to test a few of our web APIs. Thank you. Before we can execute and test any web API, we have to establish a connection between HttpRepl and our web server. If you are following this chapter, then you must have observed that each of our root templates, it starts with the segment doctor. Technically, this segment is called an endpoint. So doctor is an endpoint for our web API that we have written so far. The objective of this tutorial is to learn how to connect to a server and how to get a list of available endpoints, and how to finally navigate to a specific endpoint, which is doctor in our case. In the coming tutorials, we shall make calls to the various types of Web API that we have already added to our Web API project, and in this tutorial we will limit ourselves to connecting to our web server and connecting to the doctor endpoint. So as I told, the first thing we have to do is to establish a connection with our server. So open your project and run the application and allow the home page to open. Take note of the IP address of your server. This will be required at the time of connection. Next, let us open the command prompt. Use the menu Tools, Command Line, Developer Command Prompt to open the console. Type the command HttpRepl followed by the complete address of your server as you are seeing here. Hit the enter key, and if everything goes right, you should be able to see your IP address as a path as you are seeing here. This path is very similar to what you see on a DOS command prompt. And in fact, various DOS commands can be run here also because the names have been kept similar. For example, we can use the ls or dir command to view the various available endpoints. So now type ls on the command line on the command prompt as you are seeing here and hit the enter key. The command completes almost immediately and we can see two endpoints listed. The first one is the root and the second one is the doctor. This is the same endpoint that we have used in writing our Web API. If you want, I can open our Web API project and show this to you. Come to the Solution Explorer and locate the program.cs file. Double click and open it and scroll to the part that you are seeing here. You can see that all the route templates of our Web API start with doctor, and this is the same endpoint that has been listed by HttpRepl. Come back to the HttpRepl console. Now it is time to navigate to the doctor endpoint. Basically, we have to change the directory to doctor. The command for this is cd, which is again of the same name as the familiar DOS command called cd. So type cd followed by doctor and hit the enter key. We observe that now our command prompt shows a connection to the doctor directory. We are now connected to the doctor endpoint, and we can now execute our API connections. We can run our Web API and test them. But before that, it is possible to jump upwards in the directory tree by using the same familiar cd ... command. For this, type cd followed by two dots, and as you can see, we are back to the root. Now we are ready to test our Web API, and we shall be doing that in the next tutorials. Thank you. Now it's time to use HttpRepl for testing our Web API. To begin with, we shall test a GET API. I shall assume that your HttpRepl is installed and ready. If things appear difficult, then you may have to go through the previous two tutorials for learning the basics of HttpRepl. Open the Web API project that we have been discussing in this chapter. This project is already available in your downloads, and locate the program.cs file and scroll to the part that you are seeing here. We shall make a call to this GET WebApi. It responds with the JSON of all the records, and also recall that as we explained in the previous tutorial also, The endpoint of our web API is doctor because it appears as the first segment of the route templates of all our web API. Please go through the previous tutorial if you find it a bit difficult here. Run the project to open the home page. This ensures that the server is up and running. Take note of the address. It will be required for making a connection between HttpRepl and this server. So now let us make a connection between HttpRepl and our web API server. Come to the Visual Studio and use the menu Tools, Command Line, Developer Prompt and open the HttpRepl console window as you are seeing here. Type the command HttpRepl followed by the server address as you are seeing here. Hit enter and wait for the connection. If everything goes right, the command prompt will now show the address of your server as you are seeing here. And next we have to connect to the doctor endpoint. So type the command cd doctor and hit enter. If everything goes right, then you should now be connected to the doctor endpoint as you are seeing here. And now we can execute the call to our API. The route template to our GET API is doctor/all. At the command prompt, type GET followed by all, as you are seeing here. Hit enter and wait for the response from the server. We verify that we receive a JSON of all the records as expected. And in the next tutorial, we shall execute the POST API. Thank you. In this tutorial, we shall test our POST Web API and create a new record. So we shall have to first establish a connection between HttpRepl and our web server, and then we will have to post the JSON for the new record that we have to create on the server. Let's see how. First, let us have a look at the web API that we have to call. Open the web API project that we have been discussing in this chapter. This project is already available in your downloads. Locate the program.cs file, open it and scroll to the part that you are seeing here. We shall make a call to this POST Web API that you are seeing here. It responds with HTTP 201 and a JSON of the newly created record. Also, recall that as we explained in the previous tutorials, the endpoint of our web API is doctor because it appears as the first segment of the route templates of all our web API. Run the project to open the home page. This ensures that the server is up and running. Take note of the address and it will be required for making a connection between HttpRepl and this server. And next we have to make a connection between HttpRepl and our web API server. Come to Visual Studio and use the menu Tools, Command Line, Developer Command Prompt and open the HttpRepl console window. Type the command HttpRepl followed by the server address as you are seeing here. Hit enter and wait for the connection. If everything goes right, the command prompt will now show the address of your server as you are seeing here. And next we have to connect to the doctor endpoint, so type the command cd doctor and hit enter. You should now be connected to the doctor endpoint as you are seeing here. And now we are ready to execute the call to our web API. At the command prompt, type post followed by the JSON of the record to be created as you are seeing here. Notice that JSON is passed as a parameter. The parameter is called content. You could have used C also. And the more important thing is that it is put inside a double quotes even though the JSON itself includes double quotes. Take care of this. If your JSON is too complex or too long, then it may not be practical to paste everything here. It is possible to use an external file for this. but I'll suggest that you should go through the documentation of HttpRepl and study how to do that. I won't be able to take that here. I have taken a simple case, but you can use a file also to pass JSON and receive the result also. And now hit enter and wait for the response from the server. We verify that we have received a JSON of the newly created record with the response of HTTP 201 as expected. Thank you. So far, we have been writing all our minimal web API in the program.cs file. But this can become unmanageable and unreadable in a full-blown project. We need a scheme for organizing our web API so that they can stay in a class of their own inside a file of their own. We should even have a possibility of multiple classes, with each class containing all the related web API, those of a doctor in one file, whereas those of a patient in another file. In this tutorial, we have a brief look at the various possibilities, and finally, I show an implementation of the scheme that I personally prefer. Now, there are various possibilities of specifying route handlers for a web API. One is to have an inline lambda. It works very well for smaller projects and is even better for cases where the handler is of one or two quick lines, as you are seeing here. Another possibility is to use a local function, as you are seeing here. In this code, we have a local function called handler. This function is then used in the map-get API, as you are seeing here, and this approach could work fine for a medium-sized project. The code for your handler, it stays in a separate function, and therefore it becomes more readable to certain extent. The third possibility is to use an instance method of a separately written class. For example, we can add a suitable class to our project such as myHandler and add suitable instance functions to this class. For example, the function fx contains the code for our handler. This instance function can now be wired to the web API as shown here. As you must have noticed that we need to first create an instance of the class and then call the specific function from there. This step can be done away with by using a static class instead, and that will make it more neat also. The approach I prefer is to use a static class, and now I shall demonstrate how we can modify our existing web API project so that it uses a static class for neatly holding all our web API. Our project has about 6 web API, and now it's time to put all of them in a static class. Open the web API project and right-click to add a folder called, let's say, Web API Handlers. This folder can contain all our static classes for our route handlers. Right-click this folder and add a class called, say, Doctor Web API Mapper. Double-click and open this file so that we can examine the code. This is the file Doctor Web API Mapper.cs, and it contains a static class called Doctor Web API Mapper. We have added a function called Configure Web API to register all our 6 or 7 web API. Let's have a look at the first of them. The route handler is a separate static function of this class. The code for the API is now contained in this function. As you can see, this is more readable and neat. This class can grow as per the needs and yet remain readable. We have ported all the web API of our project to this class, and you can obtain the project from the downloads attached to this video. Let us have a look at the program.cs file also. Open the program.cs file and scroll to the part that you are seeing here. As you can see, there is a single call to the configure WebAPI function, and that we have removed all the 6 WebAPI from this file, which makes it more neat, as you can see. And now we can run the project to verify that it serves a GET WebAPI successfully, as you are seeing. We can similarly verify that other API are also working fine. Thank you. We have been obtaining our Web API parameters from route templates. A route is not the only source of parameters. In fact, the parameters can be obtained from a query string, header values, and from the body of the request also. In this tutorial, we examine how to obtain the parameters from a query string variable and how to set the parameter as optional. So first of all, create a minimal Web API project so that we can focus on this specific item of query strings. The completed project can be obtained from the downloads attached to this video. And now open the Solution Explorer and locate the program.cs file. Double click to open this file. As you can see, we have a namespace directive for Microsoft.ASP.NET Core.MVC at the top. This directive resolves the from query, the from query attribute that we have to use for decorating a parameter. And then we have the GET WebAPI that has two parameters, ID and message. The first parameter, ID, is implicitly bound to the route parameter called ID. We could have decorated it explicitly by using the from route attribute also, but it is not necessary because of ASP.NET Core defaults. And the next parameter has been decorated as from query, which means that it is derived from a query string variable called m. The handler receives it through an identifier called message. We can see that we have two different names for the same data. The name m is for the end user word for the outside word, whereas the name MSG is for the readability of our program. And the code in the handler echoes back this parameter, as you can see. Run the project and type a GET request with a URL containing a query string parameter m of value equal to 5. As you can see, https localhost m is equal to 5 is the query string variable that we are sending through the GET request. And we observe that the result succeeds and our query string variable is echoed back without errors. Let us experiment a little bit now. Remove the query string so that we are not sending any data for m. And now send the GET request. We observe that an exception is thrown now. It happens because the binding of the query string has failed. There was no variable called m. So now let us mark m as optional by changing string to string question mark. So it becomes nullable and hence an optional parameter. We can run the project again and we verify that the API call succeeds without error and m is null in this case. And this is how we can bind a parameter to a query string source. Thank you. Parameters of a web API can be obtained from the values in a request header also. For this, an attribute called fromHeader is used to decorate a parameter, and it provides an easy access to the value contained in the header of that name. In this tutorial, we shall learn how to bind a header to a web API parameter, and for continuity, please go through the previous tutorial where we saw how to bind a query string variable to a parameter. We already have a web API project that we created in the previous tutorial where we bound a query string variable to a parameter of our web API. The completed project can be downloaded from the downloads attached to this and the previous video. Open the Solution Explorer and locate the program.cs file. Double-click to open this file and scroll to the part that you are seeing here. The GET WebApi that you are seeing here, it contains 3 parameters. The first has been decorated as from route and is bound to the segment called ID. The second parameter is bound to a query string variable, and we have discussed it completely in the previous tutorial. The third parameter of interest in this tutorial is connected to a header value called user agent. An HTTP header is often used to pass additional information about how the resource has to be fetched and also about the requesting client itself. It can contain information about authentication, caching, user agent, content negotiation headers like accept encoding, accept language, connection management headers like keep alive, conditionals like e-tags, last modified, if match, and so on. This parameter has been decorated as from header, which means that it is derived from a header variable. The handler receives it through an identifier called UA and echoes it back. Run the project and type a GET request with a suitable URL. We observe that the result succeeds and the user agent is echoed back without errors. This is how we can bind a parameter to a header source. Thank you. ASP.NET Core provides certain special parameters that are always available to an API handler. These parameters are utility parameters like HTTP context, HTTP request, HTTP response, cancellation token, and claims principal. They do not need any attribute decorations like those for the query string, header, body, and route segments that we used earlier. These special parameters are not bound to any request data. They are rather instances of utility classes such as the HTTP context, HTTP response. Decoration attributes are not required and they are therefore called implicitly bound parameters. HTTP context contains information about the current request. HTTP response and HTTP request provide access to the protocol streams. Cancellation token provides us the ability to cancel the current asynchronous request, and the claims principal is about the user identity associated with the current request. Let's next have a look at an example usage of these types of parameters. Open the project attached to this video and locate the program.cs file. Double-click to open this file and scroll to the part that you are seeing here. This is a GET WebApi that receives an HTTP request as its parameter. It's a special parameter that is implicitly bound to the HTTP request without any need of attribute decoration. HTTP request provides a route values collection to extract the request data associated with the route segment. This is an alternative to the explicit from route decoration. Similarly, we can use the same request to extract query string data from the query collection. Request headers can even be read through the headers collection as you are seeing here. Run the project with a suitable URL to make a call to this web API. We verify that the API responds and echoes back the data it extracted from the route, from the query string, and from the request header. Thank you. Consider a web API that extracts parameters x, y, and z, 3 different parameters x, y, and z from its query string and then uses these values to construct a point object. For example, by passing these data to a constructor of the point class. This program can be made more readable by passing a single string of comma-separated list of 3 numbers. you can see that this is more readable as compared to passing 3 different variables. And then we have that string directly parsed into a point object. Extract the values out of that string and convert it into a point object. This technique of customized binding is the subject matter of this tutorial. Let us suppose the format of the data to be sent is a simple comma-separated list of numbers and that it has to be sent through a query string variable called p, as you are seeing here. Now since this is a tutorial, I'll keep the things very simple. Otherwise, a more readable format like a Cartesian format of brackets could be more appropriate in a real project. So we have the above string and it has to be parsed and stored in a class called myPoint. This class has 3 members to hold the 3 coordinates x, y and z. The question is, where should the code for parsing the query string be written? ASP.NET Core requires that this code should be added through a public static function called tryparse, as you are seeing here. The Web API executes this function just at the time it receives the query string. The function receives the query string into the variable string data that you are seeing, into a nullable variable string data that you are seeing here. After that, we can write suitable statements to split that string into x, y and z and return an instance of myPoint. So basically you have to have a class, and in that class you have to put a function called tryparse and that will convert it into your myPoint. So let's see it practically. We have created a simple Web API project to demonstrate this. The source code can be found in the downloads attached to this video. Open the Solution Explorer and locate the myPoint.cs file. Double click and open the file so that we can examine the code for this class. So first of all, this class has properties for x, y and z coordinates. After that, we have the tryparse function. This function receives the comma-separated string in a variable called data. The string is then split into an array and then the coordinates x, y and z are extracted. If a coordinate cannot be extracted, then it is set as a none, not a number. This function is always returning true, so it is guaranteed to succeed. Format exceptions will not be thrown by the runtime. Had this function returned false somewhere, then format exceptions would be thrown by the runtime. So it is up to you how you design the function. In my case, I have returned true, so we will have to check the data integrity by inspecting each of the variables for a none, not a number value. Another approach could be to include a Boolean data member to indicate data integrity. Come to the Solution Explorer again and locate the program.cs file. Double click to open this file and scroll to the part that you are seeing here. First, notice that the API receives myPoint without any attribute decoration. And secondly, the identifier p will automatically connect to the query string variable p and make it available to the tryparse function. Customized parameter binding of myPoint now occurs through this tryparse function. If integrity fails, we return HTTP 404, otherwise we echo back the extracted point. Let's test the Web API now. Run the project and send a GET request with a query string parameter 1, 2, 3. We verify that the API echoes the coordinates back and responds as expected. And next, let us also send a GET request of just 2 coordinates so that things fail, and when we run it, we verify that the conversion fails and we get bad data HTTP 404 error. So this is how we do custom binding. Thank you. If you already know of the task type and have now happened to meet a similar looking value task, then you are likely interested in knowing more about these types. And this article is my attempt at a quick explanation of the relation between value task and task types. Let's develop the concept step by step. A function that returns a task doesn't always execute asynchronously. It can sometimes finish synchronously. For example, consider this simple function that you are seeing. It doesn't execute asynchronously if x is less than 300. As you can see, the return type of this function is a task, and therefore it returns a task irrespective of the mode of completion. This means that there is an unnecessary allocation of task if the input is x less than 300. Well, this is a simple example that I gave, but consider the inefficiency associated with an ASP.NET Core application that has thousands of users calling async functions that happen to finish synchronously most of the time. So, before we come to the solution of this problem, we can agree on three main points. Firstly, an async function that returns a task can complete either synchronously or asynchronously depending on the conditions of execution, and possibly depending also on the state of the underlying hardware. And secondly, a task allocation will always take place irrespective of whether the function finishes synchronously or it finishes asynchronously. Each allocation takes place on the garbage collected heap because a task is after all a class. And thirdly, a heavy traffic on these functions can lead to an avoidable load on the garbage collector because some of these task allocations were really unnecessary. So we have a point of optimization. We have a possibility of optimization. We need to optimize an async code that returns a task and finishes synchronously sometimes. So such an asynchronous code can be optimized by returning a value task instead of a task. So value task is the solution here. Value task, as you must have guessed already, is a struct that can hold three types of data, but only one of them is used at a time. The three types are held in various internal data members of this struct, and let me list them. If you see the source code of this value struct, of this value task, one member is internal read-only nullable t-result underscore result. This member is used if the operation completes synchronously. This is a t-result, a direct member that holds the result of an synchronously completed operation. So underscore result will hold the result if the operation completes synchronously. And secondly, there is another member called internal read-only nullable underscore obj. This member, it stores a task. This task is for the case of asynchronous. These two members, they were originally present in this value task, but later on a third member was also added. That member is also stored in underscore obj. This obj can store an I-value task source. So underscore obj can either store a task or it can store I-value task source. This I-value task source was added later. It was added for pooling and reuse of resources. Basically, it is for optimizations, and that is beyond the scope of this article right now. You will have to go through the documentation for more on I-value task source. So at present, we can easily see that a value task can store the result directly to avoid the overhead of creating a task. Hence, we can say in nutshell that a value task is a multi-purpose struct that can avoid the overhead of creating a task if an operation completes synchronously. Now the next question is, how do we know which member contains the data of interest? Value struct, value task can hold three types of data. Now how do we know which is our data of interest, which is the active member? Whether the data is in underscore obj or is it in underscore result, how do we know? So if you see the source code, then there are basically few rules for that which are used internally only. You do not have to be concerned about these rules, but I am giving them so that we can have some sort of curiosity. We might be having some curiosity. So let's try to see those rules also. If underscore obj is null, then the operation has completed synchronously and the result is contained in underscore result. So this is the first rule. So internally we check if underscore obj is null, then the data is contained in underscore result. And if underscore obj is not null and another member called internal read-only underscore token is non-zero, so there is a third member also underscore token. If it is non-zero, then underscore obj contains an I-value task source and underscore token, it contains a token associated with it. So a non-zero token means that obj is storing I-value task source, and if this underscore token is 0, then underscore obj it contains a task. So these are the rules basically that determine which is the active data member. Now value task, it has a few limitations also. So task is the mostly used one because value task has certain limitations, and let me explain those limitations also. A value task is recommended only if your code will await it once. Multiple awaits is not allowed because value task has pooled resources. So if your code has only one await condition, then you can use value task, and especially use value task if you expect heavy traffic on a function that returns a task. Now in most of our ASP.NET Core, a value task is likely to be useful. And for more detail, please do refer to the MSDN documentation. Let's now see the things practically. Open the Solution Explorer and locate the program.cs file, double-click to open it. The same function that we started, in that case we have changed the return type to value task. The function calculate square executes asynchronously only if the input is more than 300, otherwise it executes synchronously. And inside main, we make a call to calculate square and store the result in a variable vt, and then extract the result from vt to store it in an int. So put a breakpoint as you see here and run the code by passing a value of 50 so that the code executes synchronously. We observe that underscore result, it contains the output and obj is null, which verifies that a task wasn't allocated and optimization has indeed taken place. We can similarly run the program by passing a value of 600, a value that is more than 300, so that the code will execute asynchronously. We observe that now underscore obj contains a task because the operation was asynchronous. Thus we have seen practically that a value task can hold data for both the scenarios. Thank you. Bind async is a second method for custom binding of parameters. The first one, try parts, is good for cases where the items are available in a single string, most ideally as in a query string or a header value or a route segment. But if we need a greater control over the binding process, then a more robust parameter such as the HTTP context is more suitable, and the bind async method, it does exactly that. It provides a signature that contains HTTP context as a parameter. Let's have a look at the web API that we shall use for this tutorial. Open the Solution Explorer of the project attached to this video you can find this project in the attached downloads. Locate the program.cs file and double click to open it. Scroll to the part that you are seeing here. This is a GET API, and it is the same API that we discussed in the previous tutorial on binding with the try-parse method. And in this tutorial too, we shall be binding a query string of 3 separated coordinates into a parameter of a custom class called myPoint. If the binding fails, which can be ascertained from a none, not a number, on any one of the x, y or z parameters, the API returns a 404 error, otherwise it returns 200 OK. And next we have to add a bind async function to the class myPoint. It has to be a static function that returns a value task. If you are new to a value task, then you can think of it as an optimized task. And for more, you can refer one of the previous tutorials where I have explained value task and task in greater clarity. Open the Solution Explorer and locate the myPoint.cs file and double click to open it. This class has 3 data members x, y and z, and after that we have added the bind async function. This function uses the HTTP context parameter to extract the string contained in a query string parameter p. The remaining code does the parsing and returns a value task of the parsed instance. Put a breakpoint on the return statement so that we can verify that this function is indeed called when the web API makes a custom binding. Run the project and allow the home page to open. This ensures that the server is up and running. Next, make a call to the web API by passing a query string parameter p as you are seeing here, location p is equal to 1, 2, 3. And we verify that the breakpoint in the bind async function is hit, and also that the server responds back by echoing back the parsed object. Thank you. In this tutorial, we examine how to write a web API that accepts an uploaded file and saves it to a server. We shall also present a C# console application that will call that API to upload a file to the server. Let's see how. So let's discuss the plan first. We'll write a post type of web API that will first of all read the content length header to validate the size of the incoming file. Secondly, it will generate a file of random name in a suitable folder, and then we will save the request body into that file by using a stream reader. The code for malware detection can then be added to validate the file safely, but it's beyond the scope of this tutorial, so we will not present that code, but we'll make a space where that code can be added. Open the Solution Explorer of the attached project and locate the program.cs file. The completed project can be obtained from the downloads attached to this video. And now let's double click to open this file. The first 3 lines are the usual lines for configuring the service for Razor pages. After that, we have added a post type of web API. The route template has been named as upload. The handler receives iWebhost environment from the dependency injection, and it receives HTTP context as a special binding. The client shall be sending the entire file as the body of the request, so we used HTTP context to extract the value of the content length header first. A status code of bad request 400 is sent if the size exceeds 1 MB. Next, a path to a random file name is created. The path points to a folder called uploads in the root directory of the website. This path could have been hard-coded in a configuration file and read from there also. And anyhow, the main point is that we have a path where the uploaded file has to be stored. And after that, a file stream is opened. The body reader property of the request is used to copy the bytes to the file. And finally, we can make a test for the malware integrity and any other checks on the file and save it under a suitable name. The code for that is beyond the scope of this tutorial, so we have not shown it. And lastly, we return a 200 OK JSON result. And let's now discuss the code for the C# console application. The code that you are seeing here is for the program.cs file. You can compile it in a C# console application. The code is provided in the attached downloads also. First, we have the name of the file to upload and the URL of the WebAPI endpoint. Then we have created the file and added some text to it so that we have a file that is available there, and it has been done for the purposes of tutorial only. And after that, a byte array content is created from the bytes of the file. The post async method is used to post the file to our web API, and if an exception is thrown, then a message is shown on the console, and if it succeeds, then the response message from the server side is displayed on the console. Let's now test the project. Run the server first and allow the home page to open. Next, run the console application and wait for the response. We observe that the response indicates a success. If we open the Solution Explorer of the Web API project, we can verify that a file appears under the Uploads folder, and therefore the API has worked as expected. Thank you. Basic authentication is not encouraged by ASP.NET Core because login and password ID are sent as plain text in the request header. It's vulnerable to cross-site request forgery attacks also. So there are no ready-made classes like we have for cookies-based authentication. But if your project still needs to allow basic authentication, perhaps because your security requirements are not of extreme cutting edge, in that case, we present a simple solution that helps you protect a web API with basic authorization. It can be a lot safer with basic authentication and authorization if your communication is over HTTPS, and even better if XSRF measures are taken. But these measures are beyond the scope of this tutorial, so you will have to study them at your own level. And right now, we'll talk about basic authentication in a simple manner. Basic authentication is defined in a standard called RFC 2617. You can consider going through Mozilla developers documentation for a quick reading and the associated practical aspects. A user sends a GET request containing an authorization header in the format basic space base64 of login and password. The login and password are separated by a colon. The server has to decode the header and it extracts the login and password and then authenticates the user. If the authentication succeeds, the user is served with his data as 200 OK response, and however, if the authentication fails, then the server responds as 401 unauthorized. The protocol requires that the server should also send a header www authenticate of value basic space realm is equal to followed by any purpose for which the credentials are required, which is usually a website domain. So with this simple explanation of the protocol, we have done a very crude implementation of basic authentication in the project attached to this tutorial. Open the Solution Explorer and locate the program.cs file. Double-click to open it. Let's examine the code line by line. The first few lines are the boilerplate code that we are already familiar with. Then we have a GET WebAPI that receives the authorization header through a parameter binding. After that, a check for the existence of this header is made, followed by extraction of user ID and password. Since this is a tutorial, we assume a successful verification. If authentication fails, a www or wauthenticate header is sent with a 401 response. And if it succeeds, a 200 OK response is sent along with any data requested by the client side. So we can now test the project. Run the project and send a GET request to the WebAPI/token. This request doesn't send any authorization header, so the WebAPI sends a 401 response along with the www-authenticate header as we have programmed. But almost every browser understands basic authentication and the response, so it automatically presents a login and password box. You can type any values here because anything is accepted. This server will create a base64 authorization header and make a proper call. So let's hit enter. The server accepts the call and responds with a 200 OK response. So things are going as expected. We can now test the same project with HttpRepl also. Open Visual Studio and use the menu Tools Command Line Developer Command Prompt to open a command prompt. Now type the command HttpRepl followed by the server address. This will connect you to the server endpoint. And next send a GET request get/token without any headers and hit the enter key. We expect a failure and therefore we observe that the server responds with the www-authenticate header as we have programmed. Next, make a request with a header. We can send any string for the credentials because this is a tutorial. So right now, to set the header, type set header authorization basic followed by any string which in a real project would be base64 of login and password. Hit the enter key. This will set the header and after that send a GET request get/token. We verify that the server responds with 200 OK as expected. Thank you. The recommended way of implementing a custom authentication scheme is by deriving a class from authentication handler and implementing the handle authenticate async function. This makes the code systematic because the authentication and header parsing code now moves to a dedicated class. This approach also allows us to include multiple authentication schemes in the same project. For example, you might want one web API to be authorized through basic authentication and another one through a JWT based authentication, and yet you might want your Razor pages through a cookie based authentication. In this tutorial, we shall implement the basic authentication scheme that we have done in the previous tutorial. Now I will come to the code straight away because this is a mere rewrite of the basic authentication scheme that we discussed in the previous tutorial. You might want to go through the previous tutorial for a recap. So if you are new to this, you can go through the previous tutorial to better understand this one. The source code for the project can be obtained from the downloads attached to this video. Now open the Solution Explorer and locate the file basicauthhandler.cs. Double click to open this file. At the start, we have the various namespace directives. You can always have a look at them if you get compilation errors when you write your own code. The class basicAuthHandler, it has been derived from authentication handler. This class authentication handler contains most of the boilerplate code, and so the only thing that needs to be done now is override the handle authenticate async function, as you are seeing here. The if condition parses the authorization header and checks if the scheme is basic authentication. The header is then base64 decoded and the user ID and password are segregated from the colon-separated string. After that, a database or identity-based check of the credentials can be made and an authentication ticket be created, and a success result is then sent. If some failure occurs, then a www-authenticate header is added to the response stream and a failure result is sent. We have discussed www-authenticate header in the previous tutorial, so you can have a look at that in case you find it a bit new here. This is all we need to do, and now we can examine the program.cs file. Open the Solution Explorer and locate the program.cs file, double-click and open it. Let's see the code line by line. The first few lines are the usual boilerplate code. After that, we register the authentication services. Then we have the add scheme method which connects the basic auth handler class that we added just now. And next we register the authorization services, and then the authentication and authorization middleware are added to the request pipeline. And finally, our GET WebApi is now decorated with the authorize attribute. This handler for this API will execute only if authentication succeeds. And now you can appreciate how neat is the WebApi now. Add a breakpoint in the WebApi handler. This will help us determine the flow of the program. Now let's run the project and make a request to the /token endpoint. The browser presents a credentials box. Type wrong credentials and hit enter. We verify that the breakpoint in the API handler is now not hit, and the credential box appears again. And next enter the correct credentials. User ID is HOVEN and password is 1234. Hit the enter key. We verify that the breakpoint is hit now and the web API responds with a 200 OK response. Thank you. JWT stands for JSON Web Token. In its simplest form, JWT authentication is a two-step process. First, a client obtains a JWT token from the server. This token is signed with a secure key and encrypted with the standard encryption algorithm. It has an expiry date and it contains a list of claims such as the user ID, user role, his email, etc. The client obtains authorization to a web API by sending this token in an authorization header. In this tutorial, we shall see a server-side implementation of the code for generating a JWT token and of protecting a web API. So let's see. The source code of the project has been attached as a download with this tutorial. Open the project in Visual Studio and install the NuGet package for JWT authentication. Ensure that the installation succeeds. Secondly, this project is built on the project that we have discussed in the previous tutorial where we implemented basic authentication by inheriting a class from authentication handler. You might want to go through that tutorial for a recap. Locate the program.cs file and double-click to open it. First, we have the namespaces. You can always come back to examine these if you get compilation errors. Next, we have a string for client secret. This key should not be hard-coded as we have done here. In a real project, it should be saved in a more secure place such as app settings or environment variables. The length of the key must be greater than 32 bits or at least 16 Unicode characters. After that, token validation parameters are created. Client secret is used to construct a signing key. The issuer is set to your API website and the audience is set to your web API endpoint. These are not hard and fast rules, but I suggest that you may please refer the JWT website jwt.io for finer details because that would be beyond the scope of this tutorial. The next step is to register the services for basic authentication and JWT bearer authentication. Token validation parameters are now attached as JWT bearer options. The next 5 lines are the usual boilerplate code that we already know. And next, we have a GET API that is called by the user to obtain his JWT token. This web API is authorized using basic authentication, which means that the user has to send his login and password through an authorization header. Once the user authenticates, a JWT security token is created on the basis of token validation parameters. And after that, this security token is used to obtain the string for JWT token and it is then sent as a JSON property of name access_token. It could have been of any name, But it seems that this is the name that has now become almost a convention. So we have retained that name. In our case, the user has been provided a JWT token through a call to a web API that itself is protected by basic authentication. Many websites follow this method. But this is not the only way. Some websites have a dedicated page for showing the JWT token. For this, they have a login form where the user enters his credentials, and after a successful authentication, the same page presents a JWT token along with its expiry date. The user can then copy this JWT token and use it for subsequent calls. I have seen this technique till recently on the Zoom meeting website. And lastly, we have a web API that is protected through JWT authentication. The handler need be only marked with an authorized attribute, and everything else is taken care of by the NuGet package that we added at the start of this tutorial. In the next tutorial, we shall call this web API from a client-side application. Thank you. In this tutorial, we present a C# console application that connects to the web API that we have done in the previous tutorial. This app will first obtain a JWT token by sending its login credentials in a basic authorization header, and then it will use that token in a bearer header to obtain authorization to the second API protected by JWT authorization. Please go through the previous tutorial where we have explained both the APIs. Create a simple C# console application and install the newtonsoft.json NuGet package for including support for JSON. And let's recall from the previous tutorial that we have added two web API. The first endpoint is /token. The first API is protected by a basic authorization scheme. So the caller app has to send his login ID and password in an authorization header. This API sends a JWT token in a JSON property called access_token. The second API is /info. It is protected by JWT authorization. The caller has to send a valid JWT token in a bearer header. Once he is authenticated, the handler executes and sends a welcome message. And next I'll come to the source code. You can obtain the program.cs file of the client application from the downloads attached to this video. Open the program.cs file and let's examine it line by line. First we have the URL of the server application. After that, an HTTP client has been created. We have to send a basic header containing user ID and password. This is the same pair of user ID and password that we hard-coded when we implemented basic authentication in the attached web API project. And after that, we have created an authorization header with the basic scheme. And after that, a GET request is sent to obtain the JWT token. The ensure success code function throws an exception if the response code is not 200 OK. After that, the JSON response string is read from the response. It contains the JWT token in a property called access_token. And then JSON deserialization is done to obtain the JWT token, and then in the next line it is displayed as a debug output. And after that, the JWT token is set as a bearer authorization header. An HTTP GET request is finally made to the info endpoint. The response string is then displayed on the console. And now let's test the project. First of all, run the web API project and allow the home page to open. This ensures that the web API is now listening for requests. Both these projects are available in the downloads attached to this tutorial, so you can obtain them there. And after that, run the console application with Ctrl plus F5. If everything goes fine, you will see the messages from the two API calls. The first containing the JWT token and the second containing a welcome message. JWT authorization has thus been tested OK. Thank you. Web API can be protected through social media authentication also. The first step is to obtain a client ID and a client secret by creating an app on a social media platform. Then these values are used to configure authentication services for that platform. In this tutorial, we present the sequence of steps required to gain authorization to a web API protected by Google Authentication. First of all, follow the steps explained in this video, the video that you are seeing here, to create an OAuth app on your Google Cloud Console. Secondly, take note of the NuGet package that you will have to add to your ASP.NET Core project. This package contains most of the boilerplate code for completing the login process. I have already created an ASP.NET Core project that you can obtain from the downloads attached to this video. Open the Solution Explorer and locate the program.cs file. Double-click to open it so that we can examine the code. You will have to install this NuGet package for the code to compile. Then we have the namespaces and the usual calls to create builder and add razor pages. Authentication service is configured next with the default scheme and default challenge scheme set to cookies and Google exactly as shown. The call to add cookie configures various cookie defaults. The most important settings are done through the Add Google extension. The values for client ID and client secret must match the ones shown on your Google console page. Lastly, we have subscribed to the ticket received event. This callback executes after a user has successfully authenticated from the login page of Google. We can extract the email at this point. Alternatively, we could have obtained name identifier, a unique ID maintained by social media platforms. Once you have the email ID, then you can process it in whatever manner you like. For instance, you can determine if the email exists in the project database. Then you can assign a role to the user. We have assumed that the user is assigned the admin role. Next, add this role to the claims principal. If the user fails authentication, send a 401 unauthorized response. After that, we have the usual lines for configuring the middleware. And towards the end, we have a web API that requires authentication with Google Authentication Scheme. The web API also sets the role property to restrict access to users of an admin role. Run the project to open the home page. It ensures that the server is up and running. Send a GET request to the info endpoint. But since this API requires authorization, we are redirected to the Google login website. Click on the test email and make a login. Allow the process to complete. We observe that the API executes successfully. Thus, we have a working example of a Google-based authentication and authorization. You can similarly implement Facebook, Twitter, and other authentications. Thank you. So these are exercises on Web API and exercise 1. This statement you must have already read. So let's proceed to the project. This is the project that we have created, and this is a razor page. This page has a usual directive and h1 tag, and then we have program.cs file, and this is the create builder, add razor pages, build, map razor pages, and run. So a basic working application. Let's see the output so far. It shows the home page as we would expect. So let's now configure our web API. First we have to add a singlet on. So this is the code that we do: add singlet on, and this is the type of singlet on the list, and this is the object or instance that will be added to the service. This object is added as a single instance. This only exists. So basically this is what a singlet on is, one object in the entire application. And then we have a map get, and here this is the route API all. This is the return type, it returns an OK, and the data type is returned as iList, and this is this list is obtained. This is the parameter that comes because of dependency injection. Automatically your API receives, and here the OK result is sent and the same list is sent. So this is what our API will look like. Let's run it now. This typed result will work in .NET 7 and later, so take care. So let's so this is our API that returns a JSON automatically. The API will return a JSON. Everything is done behind the scenes, and now let us do it with curl command prompt, and this is curl command. This means type of request, get request, and to this. Let's see what it does. We get the razor. Oh, we have actually sent it to the razor page itself, but we are to send it to API/all, and now you can see that we get the JSON. So we have verified it with curl also and with browser also. So this is how we do. Source code is there. Thank you. So these are exercises on web API and 2 second exercise. You must have read this. So let's proceed to the project. This is the solution that we have created, and these are the pages folder, and this is just a simple page, just a page for requirement, and this is the main story here, and this is the create builder, add razor pages, and here we add that singlet on, and this is the type list, and this is the single instance, and then build map razor pages, and then we have the get web API. This is the route, and this is the return type. First return is OK, alternate return is not found. So this is the way we can specify all the returns, results, and a comma separated list of returns. This is index coming from the route, and this is the list. This list comes from this one. This is because of dependency injection available to us, and then here we have the code, the return, extract the item based on the index, and if out of range, then type results dot not found, first return type, and this is the second return type. So this is the whole story, and we can test it now. The razor page opens, the home page opens, and now we'll test it with curl. This is the curl command. You can see this is the curl command. We are passing 22 and this says return headers. This says get return the call type, and 22 is out of range. So let us enter. We see that we get not found, and we can similarly test for 2, enter, and we get HTTP OK result. We haven't received the data because we specified I as the option for headers, and we can now remove that option. This I we can delete it off, and now we return, we'll get the grapes as the answer. So this is how the things work. Close it right now. Thank you. Exercises on Web API. Third exercise. You can read the statement, or you must have already read the statement. And now let's come to the solution. This is the project. This is the page, a razor page that has been added. It contains nothing basically. Then we have this program.cs file, the main file that create builder, razor pages, and let me show the class that we have added. At the end we have added a class product, ID, name, and now we can move up. We add a singlet on. The singlet on is a list of product, and this is the instance, one product, second product, and then we have this build map razor pages, and this is the map post, the route, the return type, the return response. It will send created response, and this is the list. This list comes from the dependency injection. Because of this singlet on, we added to the container, and this is a single instance that will be available throughout. And add an item to the list and return a created 201 response for the HTTP post, and this is the item that will be returned, and this will be the location at which this item can be seen. So these are the requirements of 201 HTTP post. And then we have this get for items, and it returns an OK for the list. This list is again the same dependency injection, and we return a OK response containing the entire list. So this is the whole story. Now we can run the application. The home page opens, and now it's time to test with curl. Curl is available on Windows 10. So this is the command that we have typed, curl I. This means headers and everything will be shown. This is the type of request, and this is where the request will go. And we can now run This is the response 200 OK, and this is the list of objects that are currently held in the list. And next we have to test the post. This is the curl command again. Curl. This is the data that is for the new item to be added. This is the header that tells application JSON format for the input. Post request, and this is the request that goes to the endpoint, and you can see that it returns 201 created along with the object that was created. And now we can again run the get command to see the, and this is 200 OK, and now you can see that it contains the additional item now. So this verifies the whole thing. We'll close it right now. Thank you. So let's take this exercise on Web API, exercise 4. This is on PUT WebApi. You can read the statement, and let me close these files first. This is the solution, and this is the index home page, and we have kept it small, simple. And then we have this program.cs file where our APIs are. So create builder, add razor pages, add singleton. This will be a list, and this is the instance. The single instance contains 2 items, and build map razor pages. The usual code, you can find it in the downloads. And this is the put request. And a put request, as you must already be knowing, is a replacement. It replaces. Put means replace. So the entire replacement, this is the ID of the item to be replaced, and this is the entire item. This is the replacement, and this is the list. This comes from the your this singleton that we added. Dependency injection provides it. Then these are the returns: no content or not found. This API will return either of these two. And these are the conditions we check. If the ID and item.id are consistent, first of all, this is required. Then we check if the item exists. It must exist in your database. So the second check is for that. This third check is really not required. It is redundant. You can remove it. So we will find out the index of the item in our database, and this item, the same item, the index is found, and then replacement is done. Then the item coming is the replacement. So this is how a put request is supposed to work. For changes, you use patch request. No content on success, and not found if some problem is there. So this is the code you can see. And then we have our map get. The list of items will be shown. This is again and OK containing the list, and this is again from dependency injection. And in the end we have the class, and these are the curl commands you can copy paste for testing purposes. Let's copy it in fact and run this application so that our home page opens. And now we open our curl. We'll now paste that command to see the current list. It says http OK and id 0 is n1, id 1 is n2. So this is the current data. And now let's copy the put request. I'll copy it and bring it to my. So this is I means that I want the entire response including headers. This is the data n3. So id 0 will be changed to n3. This will be the replacement. I'll see if instead of n3 I can write n9. N9 just for the sake of it I've done it, nothing else. It wasn't required. This is the type of request and this is the place where the request has to go. So let's hit enter. It says method not found. Some mistake I've done. Let me think about it. Okay, I got it. That I have to send the ID in the URL. So this 0 has to be sent. You can see this HTTP put. This includes the ID and now it returns no content, which means it has done it successfully. And now we should again test the products and we see that item at ID 0 is indeed replaced. So this is how your put request is working. We'll close it right now. Thank you.